Okay, we are going to begin Chapter 6, Section 2, Quadratic Equations. Now, on solving quadratic equations, the number one thing that my students typically mess up on is not reading the instructions. At this point, you know multiple ways of working through and solving quadratic equations. We have factoring, the A times B equals 0 property. You have the quadratic formula, you have square root property. So you already know multiple ways, the quadratic formula, okay? And so the thing that you have to keep in mind is reading the instructions. So on problems 1 through 20, it says solve by factoring and by applying that product property, zero product property. Okay, and that came back from chapter 3, that factoring business, okay? So the very first thing we want to look at is when you have a problem that is a binomial, that means you have two terms. Terms are separated by plus and minus signs. The first step in factoring is to take out a greatest common factor. We notice that there is an x in both an x squared and a 5x. X squared divided by x is x. 5x divided by x is 5. We have two things now multiplied together that equals 0. Well, you know 0 times anything is 0, so x has to equal 0 for that to be true, or x plus 5 equals 0, which means x could be a negative 5. So we have two answers. X is 0, x is negative 5. When we move along, we have to look at both the variable and the number. So we still have a binomial. So the greatest common factor is a 3 and a y. And remember, if you can't remember, you can always use the calculator where it has greatest common denominator to find the greatest common factor in 3 and 12. Okay, so 3y squared divided by 3y is y. 12y divided by 3y is 4. Again, we now have a product, two things multiplied together to equal 0. So 3y equals 0, or y plus 4 equals 0. We're going to divide by 3. 0 divided by any number is 0. We're going to subtract the 4, so y is a negative 4. Okay, so we are going to move on then to what if we have a trinomial? Okay, in a trinomial, we're going to remember those factoring techniques from chapter 3. So the first thing I am going to do is I am going to look at my factors 24 times 10. So that's 240. Now remember, on the calculator, we can push y is equal to, and we can do 240 divided by x, and then go to our table, and we're looking for factors that subtract to give you a 1. Well, if they subtract to give you a 1, those numbers need to be close together, okay? So 15 and 16, there we go, 15 and 16. So we're going to replace the x with a 16x minus a 15x. And then we're going to factor by grouping. The greatest common factor in 24 and 16 is 8, and the greatest common factor in x and x squared is x. And the greatest common factor in a negative 15 and a negative 10 is a negative 5. So that leaves us a 3x and a 2. Now, the factor by grouping, we notice that there's a 3x plus 2 that's in common. So we're going to take out that 8x minus 5 and the 3x plus 2. And now each of those equal to 0. So 8x minus 5 equals 0. We're going to add the 5. 8x equals 5. Divide by 8. So x is 5/8. We're going to set the 3x plus 2 equal to 0. We're going to subtract the 2 and divide by the 3. And x is a negative 2/3. Okay, so using our techniques from back in chapter 3. Okay, so from 21 to 26, solve each radical equation. Don't forget you must check for potential solutions. Okay, so on problem 22, and we just had a test over solving radical equations. So remember, with radical equations, you have to have a radical on a side by itself. All right, so this is a radical multiplied by 3 equal to a number. So how do you get rid of the radical? Well, you would square both sides. So let me show you. I don't like fractions, so I don't want to divide by 3. I want to go ahead and square. Now, students typically mess up on squaring this binomial. Remember, a square means you have the base. The base is x plus 4, and that base is written that exponent number of times. Now, the rule for multiplying and dividing is everything inside the parentheses is raised to that power. This is all multiplication. Notice there's no plus or minus sign. 3 squared is 9, and the square root of 2x squared is just 2x. 9 times 2 is 18x. FOIL, double distribute, combine like terms. From Algebra 2, we know that we need to solve a quadratic trinomial by setting it all equal to 0. So we're going to subtract that 18x, x squared minus 10x plus 16. All right, so we're going to unfoil, if you will. What did you multiply together to get the x squared? What are factors of 16 that add to give you a 10? 8 and 2. Because we are adding, the signs are the same as the middle, so negative 1 and negative 8 rather, and negative 2. Now remember, 1x squared times 16 is 16, so you still could use that factor by grouping method. Set each of these equal to 0. So 8 equals x minus 2 equals 0, add 2, x is 2. All right, now we've got to check to make sure that the original problem, 3 square roots of 2x equals x plus 4. So we're going to try both of these, and I'm just going to show you how to do this in the calculator pretty quick. We have 3 square root of 2, and our first x we found was 8. Well, that's a 12. So if I do 8 plus 4, which is the right-hand side, it is also a 12. So 8 checks. 3 square root of 2 times 2. 2 is our second x. We get a 6. 2 plus 4 is 6. So therefore, we know that both our answers are fine. We have no extraneous roots. Moving on to problems 27 through 62. Okay, we're going to start with everything that we've already know, but we're adding that negative in. To undo a square, we're going to square root. Now this is the absolute value of that, so we have a 6i. Well, the absolute value says there are two numbers from 0 on the number line, so remember you're going to have two answers. When you have problems that have a number in front of, the first thing you want to do is divide and get rid of that number to get the variable with the square on a side by itself first. Okay, so then we have the 18, and now we're going to take the square root. And from the test and from the last section, we know that 9 times 2 is 18, and 9 is our perfect square. So there are two numbers, plus and minus, 3 square roots of 2. As you get into the problems, they become a little more advanced It's the same concept, the same idea. Okay, so you have this x plus 1 quantity squared. Now, some of you are going to be tempted to just FOIL this out, but we're wanting to solve and we want to do it in the quickest time possible. So what's another way to undo a square? Well, it's to take the square root. So if the problem, quantity squared, is already on a side by itself, you can just take the square root. And remember, we took the square root, that's the absolute value, so there's two of them. And so we have a plus 4 and we have a minus 4. So then to solve for x, we're going to have to subtract 1. So negative 1 plus 4 or negative 1 minus 4. So you're going to have two different answers, 3 and negative 5. Okay, so moving on, again, we're going to get a little more in depth. So let's look at 62. We have 3. We have parenthesis 4x minus 1 quantity squared plus 1 equals that negative 17. So remember, when we have this problem or radical problem, we want to get the x on a side by itself before you start doing anything else. So the first thing we need to do, our x is here inside this quantity squared business. So we're going to subtract the 1, copy down the rest of the problem, divide by the 3 to get the variable that's inside that square on a side by itself. So now we're going to square root both sides. That negative is underneath the radical, so that's the I. The plus or minus goes in front of your number. That leaves the 6 underneath the radical. We're going to add 1 to both sides. And this is going to start looking a little bit odd because now we have a plus or minus, 1 plus or minus, and then we're going to divide by the 4. And you can't actually do the adding, multiplying, or the division. So you're done. That's the best possible answer you can get. All right, so let's kind of shift gears for a little bit. We're going to go into back to geometry for a bit. Okay, so you have a right triangle, and in a right triangle, we have some angle of measure. And in that angle of measure, the side opposite means it's the side that does not make up those two sides. Okay, this side opposite is also called a leg. We have another angle opposite it is another leg, and then we have the side opposite the 90 is the hypotenuse. Okay, so if we have our triangle labeled, typically the way they label them, capital letters are going to be the vertices or the points. The sides opposite those are going to be the lowercase letters. Okay, so on problem 64, it says that you want to find C. We don't know C, but A is 3 and B is 7. Well, in a right triangle, given the legs, we do leg squared plus leg squared equals hypotenuse squared. Okay, so 9 plus 49 equals C squared. 49 plus 9 is 58. Now, when we are looking at 58, there's not a perfect square when we take that square root. So the square root is 58. And on 64, these were measured in meters. So we've got the square root of 58 meters because we want it in simplest radical form, not a decimal approximation. So remember the Pythagorean theorem, a squared plus b squared equals c squared, is just telling you leg squared plus leg squared equals hypotenuse squared. The other thing that we need to look at is some special right triangles. Okay, in a special right triangle, we have an isosceles right triangle. So remember some definitions. Isosceles means these leg are the same because this is a 45, 45, 90 triangle. And from geometry, we said that we could take this leg and we could say leg square root 2 to get the hypotenuse. So that's that shortcut from geometry instead of doing the Pythagorean theorem. The next thing that we want to look at is in a 30, 60, 90 triangle. The short side is opposite that 30. The long side is opposite the 60. And then we have the hypotenuse again across from the 30. Now the trick is the long side is the short side times radical 3, and the hypotenuse is 2 times the short side. Okay? So if I'm wanting to do a problem from 73 to 78, and I have C, which in 73 to 78, when you look at it, they've drawn their triangle backwards from the way I have mine, but C is the right angle, lowercase c is opposite it, B is the 60-degree angle, A is the 30-degree angle. And all we know on 76 is that C is 9. Okay, well, if C is 9, it goes here, and this is a 30, 60, 90 triangle. I could use the Pythagorean theorem to try to get it, but it's actually faster if you find the other sides. Okay, so I know that 30 is my capital A, so my lowercase a is the short side. And I know the hypotenuse, which is 9, is double the short side. So to get my short side, I would just divide 9 by 2. And then to get the B value, I've got my short side times the square root of 3. And in 76, they are talking about centimeters. So 9 over 2 centimeters, 9 over 2 times radical 3 centimeters, and you're done. A lot faster if you know those shortcut rules. Good luck.